Hello, everyone. Good morning, good afternoon, good evening. Dear authors and invited guests, welcome to the technical session 4I. Myself, Anshika Jain, and this session would be moderated by me. I, on the behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on Information and Communication Technology for Competitive Strategies, ICTCS 2025, Jaipur, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Jaipur, India, and the virtual event is being held through Zoom today and tomorrow, that is 16th and 17th December 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we will have 10 presentations, and each presenter will be given 10 minutes for the presentation and 2 minutes for the questions and answers. On 9 minutes, I will raise a very gentle reminder. There is another request to all the participants that you stay connected with us till the closing remarks. If you have any query or any update, then you can write it to me in the chat box below. Just before we get started with the session, I would like to introduce you all to the chair for this session. Dr. Suresh Limkar. Sir is an assistant professor at the Central University of Jammu, India, with 15 years of academic experience. His academic interests span the Internet of Things, cloud computing, machine learning, deep learning, and cryptography. Sir is dedicated to advancing research and education in emerging technologies, contributing to both scholarly development and the training of future computing professionals. Welcome to the session, sir. Would you like to share a quick opening remark with us? Uh, so, would you like to share a quick opening remark with us? Okay, so we'll be starting with the papers now. First, we have R. Vanlal Vampuya to present the paper title A Determinative System of Lifestyle of Type 2 Diabetes Mellitus in Meso Community using Explainable AI. Are you there?
Yes, madam.
Yeah, you may please begin with your presentation.
Okay, thank you so much.
Anshika, I have a couple of questions or just
Yes.
points here.
Yeah,
So
sure,
just
sir.
let me know, are you going to evaluate it or how I should evaluate it? Or is there any
Uh,
uh, best paper award that need to be find out from this particular session?
no, sir, no, there's nothing like that.
Okay,
Yeah,
sure. Yeah,
thank you.
thanks.
Okay, madam, may I proceed?
Yeah, you may please share your
Okay, thank
screen.
you so much. Okay, thank you so much. Is my screen visible?
Yes, your screen is visible. You may please start.
Okay. Has my presentation came up? Excuse me. Wait. Wait, there's some Tisolo. Okay. Good morning, everyone. And today I'm going to present a deterministic system of lifestyle of type 2 diabetes mellitus in Mizo community using explainable AI. And my name is Val Umpuya. I'm from Mizoram University. And my department is, as you can see here, computer engineering. And the content of my PowerPoint would be introduction and literature review, data collection, experiment and discussion, results and discussion, and lastly, our reference will be there. Excuse me. Boy, okay. Diabetes has been a significant health concern over decades all over the world. And in India also, this has been a prevalence. And diabetes has uh, risen due to many reasons. Insufficient insulin secretion, and that's make the sugar more in our blood. and diabetes impact global is also rising, and this is a health concern for um, the world, and unveiling the hidden factors and the reasons of diabetes prevalence uh, is various, and this diabetes also can increase due to many factors, uh, by conducting unhealthy lifestyles, or it can also come from genetic predispositions or community practice such as eating bad eating habits, or observe and poor diet or lack of exercise, family history increases, and environmental factor contribute to diabetes also. And type 2 diabetes prevalence in India and Mizoram. As you can see here, India is the second highest diabetes population globally, and Mizoram is also start having the type 2 diabetes, and 29 percentage of out of populations are uh, having this type 2 diabetes. And the study proposed a random forest to uh, epidemiological data attributes containing 94 0.25 accuracy rate and AOC of 95 using P. And logistic regression was unable to identify significant risk factors, and the researcher implemented neural network of multi-perceptron forecasting the period of time and to diagnose the person with type 2 diabetes. And these methods gained the accuracy of 95.2, outperform of other models on clinical and biochemical and microbiome data. And data normalization and data normalization, and these techniques apply to increase training efficiency and lower chances. And similarly, excuse me. Similarly, a study in Ethiopia, class imbalance was handled via synthetic majority oversampling techniques, SMOD, and in type 2 diabetes, and with a recall of 99%, an area under curve of 99% suggested support vector machine, and classifier outperformed the other models in the test. And another group employ an advanced hybrid machine learning model that combines certificated features selected method using enhanced Levi flight-based Fruitly optimization algorithm, and support vector machines also employed here, and the model was able to predict type 2 diabetes with 93.50 accuracy from UCI repository data comparison of 8 attributes. So improving type 2 diabetes detection. So how here we are going to identify the existing problem. First of all, the gaps in type 2 diabetes mellitus detection. Actually, in the existing system, what we have seen is that inconsistent and non-inclusive models. And another one is that unified XAI and ML pipeline is hardly used here, and epidemiological data set center data in meso urban areas. We are going to use this data purely from this meso population, and also with the consent of these participants, we are taking this data, and inclusive CVT in research highly applicable across ethnic group. Actually, Mizo population is individual population. The cultures is also different, and the culture practice is also different apart from the world, because the way they take a food, and they are using white food as the main food. And improve type 2 diabetes detection. We are going to improve it, type 2 diabetes detection, in the way that we can. And data description, as you can see here, our data is consisting of various attributes, as you can see here: age, sex, and dietary habits also containing 4 attributes such as meat, smoked meat, and salt, and lifestyle choices like cigarettes, tibur. And you can see here sex is represented as 1, and male is represented as 1 and 2 is represented as female, and age is a continuous number, and meat is represented if the person is consuming more meat, and it's more meat, which means we represent it as 3. And if a person is consume average, and we represent it as 2. And if a person is consuming less, then we represent it as 1. And if the person doesn't have a meat at all, then we represent it as 0. Likewise, for cigarettes, sada, tibur, and pan also we are represented in this way. And this is our methodology. First of all, we collected our epidemiological data. Then after that, we are conducting pre-processing, and we are removing all the missing values and normalize. And after that, we have done normalization. And our data is split into train data set and test data set. And as we can see here, our train data set is 80% and test is 20%. And after that, we have trained using the knife bias and random forest classifier, and also we are using k-fold training. And here tuning, also we have to do a tuning hyperparameters using research CV. Actually, the reason we're tuning is that in order to improve the prediction accuracy. And also we have evaluated the performance using accuracy and precision, recall, F1 score, and overall score, and the overall score is also has been recorded. Then after that, we have applied type 2 diabetes detection. Then the result is also displayed using a SERP for models. As a SERP is a explainable AI. From the result, we can explain all the how it has been read the data. And experimental data and discussion. Here, we have, as we have seen here, we have taken data, then after that we split, and also we have done pre-processing. I think I will have skipped this one. Now, let me talk about the models we have used in the machine for the machine learning. Number one is random forest. Random forest. This one is used. The reason is that to minimize the computing resources and control time complexity parameters, such as average, average classification time. And also we have using knife bias, and this is a control independence, and also it is it's calculating probability time of the data, and after that it have given the final prediction. We are also using gradient boosting. Gradient boosting is a sequential model building, and is also is correcting the previous whatever the previous models are making. This is why gradient boosting has been applied here in this experiment. And these are the results we have seen so far. And this section elucidate the results and analysis of different classifier are ran through their corresponding parameter as presented in table 1 here, with the random forest hyperparameter tune using research CV as shown in table 2. Here, as you can see here, knife bias is skewing 87.40, and gradient boosting is skewing 92.80, and random forest also skewing 93.80, and precision for knife bias is 83.24, and for gradient boosting is 93.82, and for random forest 93.89. As you can see here, for sensitivity also we have recorded here. For F1 scores also we have recorded here. As I said, we have applied research CV for random forest. The reason we are applying this research is that in order to prove in order to have improvement in the accuracy and overall the matrices. And here, after applying the research review, we have seen here for the test we from 93.0. Before the accuracy is 93.80, but after applying the research review, then the accuracy has been come up by 1%. That is, then it came up to 94.2. And this is a correlation heat map. As you can see here, the correlation heat map smoke meat and uh, smoke meat consumption and small meat consumption and palm consumption coefficient is almost 2.0. That is, they are very high comparing to other features. And here we are.
Sorry to interrupt you, sir, but please conclude your presentation.
Okay, thank you so much. Okay, this is the result. This is the confusion matrix, and in the confusion matrix, zeros represent non-diabetes, and one represent diabetes. And here the misclassification for non-diabetes is only 2, and for uh, diabetes is only 6. And here is the matrix graphic results for our research. And these are sub value, and smoked meat has is skew highest. And in the meantime, palm consumption is also, as we said, second highest. And this is the served values for our studies features represented by serve system. Okay, these are the references that I have, and from number 1 to 10. I think that's all that I can present. Thank you so much.
Thank you so much for your presentation. Sir, do you have any questions?
Yes, I have a couple of questions.
Okay, thank you so much, sir.
Yeah. Please let me know what is the motivation to select random forest, new bias, and the gradient boosting? Because so already most of the papers have done this or they have used it in their research paper. And second, I didn't find any novelty in this paper. What the novelty you introduced? Can you just brief it?
Okay, thank you so much, sir. Actually, the reason we are using this night bias, gradient forest, and gradient boosting is that uh, in uh, in our community, no one has been using this. I'm talking about in Mizo community only, okay, sir. Because this is the first study uh, in especially to Mizo populations. The reason you're using is that random forest and gradient boosting, they are very basic, and uh, the way it calculate and uh, the way it make decision is very simple. As our data is also very simple, that's the main reason we are using this gradient boosting, random forest, and night bias, sir. And the novelty about this one is that, sir, as I said, this data is purely taken from Mizo population, and Mizo population, as I said, is any group, the individual group, and their community practice and their living lifestyle habits is also totally different apart from these Indian cultures. This is, sir. Am I answering your question, sir? Excuse me, sir.
Sir, are you there?
Yes. Yeah, I'm just going listening. Okay.
Okay.
So from my end, questions are over.
Thank you so much for your presentation. We'll be moving on to the next presentation.
Okay.
Next, we
Thank
have
you so much.
Narmatha to present the paper titled AI Enhanced Inquiry-Based Learning and Personalized Problem Solving for Improving Engineering Education. Namrata, are you there?
Yes, ma'am, I'm here.
Yeah.
Excuse me. Excuse
Narmada.
me.
Yes.
Okay.
Yeah. You may please begin with your presentation.
Yeah,
Stop sharing. You can share your screen.
Is my screen visible?
Yes, your screen is visible. You may please begin now.
Good morning, everyone. I'm Narmata Sri, and today I'll be presenting our work on AI-enhanced inquiry-based learning and personalized problem solving for improving engineering education. This is a survey-based study. So first, our work is divided into three core concepts such as inquiry-based learning, personalized problem solving, and the integration of AI with this. So to begin with, inquiry-based learning is an active learning approach where students are encouraged to explore concepts by asking questions rather than passively receiving information. And in this model, the teacher's role shifts from being a traditional lecturer to a facilitator who guides students through the learning process. And this approach also promotes critical thinking, problem solving skills, and a deeper understanding of concepts because students actively engage with this material, not this rote memorization problem. For example, instead of directly teaching a topic like circular linked list, students can begin with a question, explore possible solutions like what is the disadvantage of singular linked list, and then discuss their findings. This process helps them understand not just the how, but also why behind the concept. And the next is personalized problem solving. Here, while the inquiry based learning encourages exploration, students also differ in their abilities, interests, and career goals. And this is where personalized problem solving becomes important. It focuses on adapting problems and learning tasks to suit individuals' needs rather than following a one size fits all approach, which is followed in the traditional teaching. Because and also in traditional classroom, achieving this level of personalization is difficult due to the time constraints and limited human resources. And as a result, this may either feel the students underwhelmed or overwhelmed. So, by aligning problems with students' career goals and learning styles, personalized problem solving encourages students to take ownership of the learning and improves motivation, engagement, and long term knowledge retention when the learning is connected to real world applications. And the AI integration. So, there are two major challenges such as time constraint and human resources. Not every professor can't handle all the students. So, to address the challenges of implementing inquiry based learning and personalized problem solving at scale, we propose the integration of artificial intelligence. AI can support inquiry based learning by generating questions that encourage exploration rather than directly providing answers. It can also adapt the difficulty of tasks based on students' performance and career interest. And AI can provide real time feedback in the form of hints, explanations, and follow up questions. And by suggesting personalized learning paths and reducing cognitive load, AI allows students to focus more on creative side and critical problem solving while still receiving the traditional structured support. And the literature review is sectioned into three, which covers inquiry-based learning focus, and then AI and inquiry-based learning, and then personalized problem solving. The papers in this section concluded that IBL, that is inquiry-based learning, improves motivation, engagement, and students' better attitude. And students also become better problem solvers, and they apply the concept that they learn practically, and it also fosters creativity, design motivation in students. And in the next section, our findings include the teacher-student AI collaboration reduces cognitive load, boosts creativity, and also AI supports personalized problem solving and guidance. And LLM models in learning improves engagement, social emotional growth, and personalized learning outcomes. And when it comes to personalized learning and career relevance, the findings concluded that it improves critical thinking, analyzes learning to career goals, and enhances learning performance, higher order thinking in students. And when using ChatGPT and such models for studying, the studies conclude that it identifies enablers such as self-learning, personalization, and barriers such as privacy and guilt. Coming to the research methodology, this study follows a quantitative survey-based approach. The primary goal of the survey was to understand students' perceptions of AI-enhanced IBL and personalized problem solving. A survey method was chosen because it is time efficient and suitable for collecting data from a large group of respondents and effective in identifying patterns and collections in students' responses. And the survey design, the total number of participants were 101 engineering students. Among them, 56% were male and 44 were female. And the diverse category of students, such as undergraduate, postgraduate, and doctoral students, gave us a diverse academic perspective on the survey. And the sampling technique was convenient sampling, people who are willing to participate and easy to access, and was shared among the university groups in classroom format. And the participation was anonymous and voluntary, and this was ensured to all the participants. And the survey design, it consists of 15 questions and was divided into 4 attributes such as IBL knowledge, perception, motivation and career relevance, and AI support and AI tools. The data collection process, the form was created using Google Forms and distributed via college groups, classroom announcements, and peer networks. And the responses were automatically recorded and then exported to Excel for statistical analysis. And statistical analysis performed were descriptive analysis, reliability, correlation, factor, and regression analysis. This was done using PSPP software. And the proposed architecture for this methodology can be divided into input, process, and output. Input is all the participants that will be involved in this methodology. The students, teachers, AI tools, and the materials that will be created by both the AI and the teachers. And the process include the 5 stages in this methodology. So it starts with inquiry, a question, and then the students can explore possible solutions and analyze solutions and reflect and collaborate with the fellow students. And the output will be improved conceptual understanding, enhanced problem solving skills, increased motivation, career goal alignment, and confidence in AI supported learning. And this is like a continuous learning improvement. And the results and discussions. The descriptive analysis showed lower awareness and usage of IBL. So this concluded that the concept of IBL is still new to many learners, and they expressed strong positive perceptions when after introduced to IBL's effectiveness with the mean value of 3.7 to 3.9. And among the analysis, career alignment received the highest agreement with the mean value of 4.15, showing that the students value skill relevance. And AI tools and support also received positive responses. And before further analysis, the reliability of the survey instrument was assessed, and the questionnaire was initially validated by a subject expert. The reliability analysis yielded a Cronbach alpha value of 0.87. This indicated an excellent internal consistency, and this confirms that the instrument is reliable and suitable for advanced statistical analysis. And the correlation analysis revealed significant positive relationships among inquiry-based learning perceptions and AI-enhanced learning factors. Students with higher awareness of inquiry-based learning demonstrated better conceptual understanding and clarity. A strong positive relationship was also observed between AI-enhanced inquiry-based learning and students' confidence in solving real-world problems. And an alignment of learning with career goals showed a significant association with confidence in using AI-supported learning tools. Now, to further examine the predictors, regression analysis was performed. The regression model explained 65% of the variance, indicating a stronger model fit. And 2 significant predictors were identified. AI-enhanced inquiry-based learning combined with career alignment showed a significant influence, and inquiry-based learning effectiveness along with collaboration also emerged as strong predictors. This suggests that students perceive AI-enhanced inquiry-based learning as most beneficial when it supports collaboration and aligns with their career aspirations. And factor analysis was performed using principal component analysis to identify the underlying dimensions in the data. 4 key components were extracted as it can be seen by the scree plot, and explaining 65.7% of the total variance. These factors represent AI-enhanced inquiry-based learning with career alignment, IBL awareness and usage, IBL effectiveness with collaboration, and traditional teaching methods. Overall, the findings indicate that while students may initially be unfamiliar with IBL, they show strong acceptance once exposed to it. The integration of AI enhances clarity, motivation, and confidence in applying knowledge, and particularly in real-world problem-solving context. And factors related to career relevance demonstrate the strongest positive impact, whereas traditional teaching methods show minimal influence on perceived benefits. These findings highlight the potential of combining AI with inquiry-based learning to create more engaging, personalized, and future-ready engineering education. And to conclude, this study demonstrates that integrating AI to inquiry-based learning can create a more adaptive, engaging, and effective learning environment. By combining NLP-driven question support, personalized problem-solving pathways, and real-time feedback, the proposed framework enables students to explore concepts more independently while still receiving tailored guidance. Overall, the AI-enhanced approach strengthens learner autonomy, improves problem-solving efficiency, and shows stronger potential for scalable use in the constantly evolving engineering education. And since the study is survey based, future work will focus on validating these findings through quasi experiments such as classroom based implementation. The study can also be extended to larger and more diverse group students, along with comparative analysis. Additionally, prototype can be built and evaluated to practically support inquiry based and personalized learning. And these were the references. Thank you.
Thank you so much for your presentation. Sir, do you have any questions?
Only one question from my end.
Yes, sir.
So what motivates you to select this topic? And if you get a chance to extend this topic, so how you would like to extend this particular topic?
Okay, so I was always fascinated by the teaching methods that our staffs use when teaching coding and lectures. They use different kind of techniques, and what particularly attracted me the most was inquiry, and a particular staff usually starts with the question, and I wanted to learn more about that, and I started researching this. That is what motivated me. And to further enhance this topic, I would like to propose an experiment with actual students and how they behave with this inquiry-based learning and how the performance differ when compared to traditional and inquiry-based learning. That's it,
Yeah.
sir.
Okay, from my end, questions are over.
Thank you so much, sir. So we'll be moving on to the next presentation now. Yeah. So next we have Satish to present the paper titled DDoS attacks detection in software-defined networks using multi-feature selection, extreme gradient boosting, and recurrent neural network. Are you there, Satish?
Yes, ma'am.
Yeah. You may please begin with your presentation.
Is the screen visible, ma'am?
Yes, your screen is visible. You may start now.
Good morning, respected chiefs, judges, and participants. I am Satish Vaishar from Kelly Technological University. Today, I will be presenting our research work on detecting DDoS attacks in software-defined networks using a hybrid selection approach combined with the XGBoost and RNGRU models. This work focuses on improving detection, accuracy, and real-time feasibility, especially in IoT-enabled SDN environments. I will begin with the brief introduction to SDN and the problem of DDoS attacks, followed by our motivation and objectives. Then I will explain the dataset, proposed architecture, feature selection strategies, and the machine learning and deep learning models used. Finally, we will discuss the experimental setup, results, key takeaways, and conclude with the future scope. Software-defined networking improves network flexibility by separating the control plane from the data plane. However, centralization makes the SDN controller a critical vulnerability point. During DDoS attacks, attackers flood the controller with the excessive flow requests, leading to performance degradation. This issue becomes more severe in IoT environments due to high device density and unpredictable traffic patterns. Hence, accurate DDoS detection requires strong feature selection, temporal modeling, and scalable ML and DL techniques. The core problem is that SDN controllers became bottlenecks during DDoS attacks. Many existing systems fail because they rely on weak or a single plane feature selection and lack generalization. Most prior work analyzes either control plane or data plane features in isolation. Using only one feature selection method often leads to overfitting or underfitting. Therefore, IoT SDN networks need adaptive, scalable models that can capture both statistical and temporal traffic behavior. Our first objective is to identify the most crucial SDN traffic features using a hybrid feature selection approach. Next, we train XGBoost and RNA-GRU models for accurate DDoS detection. We evaluate these models using a CIC IoT 2023 dataset detection. To validate real-time feasibility, we implement the solution on a Mininet and POX-based SDN environment. We compare machine learning and deep learning models in terms of performance and practicality. We use the CIC IoT 2023 dataset, which contains diverse IoT-based Venegan and DDoS traffic. It includes both flow level and packet level features, representing realistic network behavior. The dataset covers multiple attack types, helping models generalize well to SDN environments. It also provides a high resolution temporal patterns, which are particularly useful for sequence based models like GRU. Additionally, it includes well labeled ground truth, enabling accurate supervised learning. Our methodology begins with the pre-processing the CIC IoT 2023 dataset. We extract both statistical and temporal features relevant to SDN traffic behavior. The dataset is cleaned and prepared for supervised learning. This processed data is then passed through a hybrid feature selection stage. The selected features are finally used to train the and evaluate the XGBoost and RNN-GRU models. This slide shows the overall system architecture. The input consists of a traffic data from CIC IoT 2023 dataset and Mininet emulated SDN traffic. In the pre-processing stage, select k-based ANOVA value.
Hi, Satish, I cannot hear you. Satish, are you there? Satish, are you there? Okay, I guess somebody has joined. Yeah, Satish, are you there from the another ID?
I think
Okay,
some
I
technical
guess
issue
some
or
network
power
issue.
failure issue might be there. So
Yeah,
we'll
so
just wait for 5 more minutes.
yeah, we can wait for 5 minutes, then we can continue with the next presentation.
Yeah, if he couldn't able to join, then we can proceed for the next one.
Yeah.
Sorry for the
Yeah,
yeah.
no problem, Satish. You may please continue.
Yes. Is my screen visible?
Yeah, your screen is visible. You may please continue with your presentation.
Yeah, thank you. Feature selection is a key contribution of our work. We combine select k-based, ANOVA F value, and random forest features importance. This hybrid approach helps capture protocol behavior, packet variations, and flow structure. By selecting only top 10 most relevant features, we reduce dimensionality. This improves classification efficiency and reduce computational overhead. We use two complementary models, XGBoost and RNN-GRU. XGBoost is a powerful machine learning model that learns complex traffic patterns. It provides high precision, low false positives, and extremely fast inference, making it suitable for SDN controllers. RNN-GRU, on the other hand, captures the sequential and the temporal flow behavior. It achieves high ROC AOC and is robust against time-dependent attack patterns. So this is our experiment setup. We evaluate real-time performance. We use a mininet topology with the POX controller. Core and the distribution switches manage traffic generated by the multiple IoT hosts. Flow statistics are continuously collected from switches. These statisticals are then fed into the trained ML and DL models for real-time classifications. These are the ML results. Among the machine learning models, XGBoost achieved the best performance. It reached 99% accuracy, 99% precision, and 98% recall. Logical regression achieved 98% accuracy. SVM performed poorly with only 58% accuracy and higher false positives. These results confirm that the XGBoost is highly reliable for the SDN deployment. This slide visually compares the performance of ML models. The accuracy graph clearly shows that the XGBoost outperforming logistic regression and SVM. The recall and the F1 score plots further highlight the imbalance and the poor reliability of SVM. Overall, XGBoost provides the most balanced and the stable performance. These are the deep learning and mini-net results. In the real-time SDN evaluation, both models performed especially well. XGBoost achieved 99.9% accuracy with extremely low latency, and RN and GRU achieved 99.4% accuracy with ROC AUC of 0.99. The confusion matrix shows minimal misclassification, and RN and GRU captures temporal behavior effectively while XGBoost dominates in speed. This slide, the ROC curve shows that the RN and GRU model has strong discriminative capability, and AUC value of 0.99 indicates an excellent separation between the benign and the attack traffic. The confusion matrix shows a very few false and false positives and the false negatives. This confirms the robustness of deep learning models in real world scenarios. The key takeaway from this the hybrid feature selection significantly improves detection accuracy. The XGBoost offers near perfect detection with very fast inference, and RNN GRU excels at modeling evaluating attack behavior. Both models outperform many of these existing SDN DDoS detection methods, and MiniNet evaluation confirms practical development and readiness. So, in conclusion, our hybrid feature selection combined with XGBoost and RNNGRU provides us high accurate DDoS detection in SDN environment. XGBoost is a real-time deployment due to its speed, while RNNGRU effectively captures the temporal patterns. MiniNet evaluation confirms scalability and reliability. As a future work, we plan to integrate adaptive online learning, reduce model so that it can reduce model complexity for edge devices, extend to multiple controller SDN, and combine detection with automated mitigation. These slides list the key references that support our research, including the recent IEEE and Springer publication related to SDN and DDoS detection. Thank you for your time and attention. I will be happy to take any questions.
Thank you so much for your presentation. Sir, do you have any questions?
Yes, I have only one question. So just wanted to know how you simulated DDoS attack on software defined network platform.
Sir, we have done it with respect to using the Mininet. We have done the installation and we have taken up the POX controller. Using the Python, we have implemented and we have taken approximately around 100 hosts, and with the multiple switches, we have done the simulation, sir. Even like in future, we have got our private lab set up with a cloud environment in our university. So we are also planning to go ahead with closed environment. We are trying to simulate the leading college network. So we are planning to establish our private network with our private cloud lab setup and then go ahead with it.
Okay, from my end, questions are over.
Thank you so much for your
Yes, sir. Thank you,
presentation.
sir.
Thank you, sir. We'll be moving on to the next presentation. Next, we have Sujata to present the paper titled Feature-Based Deepfake Detection Using LBP and HOG with Machine Learning Approaches. Are you there?
Yes, ma'am. Yes. I'm
Yeah.
just sharing my screen.
Yes, you may please start. Yeah, you can.
Whether my screen is visible?
Yes, your screen is visible. You may please start now.
Okay. So good morning, everyone. I am Sujata Bahadure from Ramrao Adik Institute of Technology, and Today I am going to present on a topic feature-based defect detection using LBP and HOG with machine learning approaches. So with the advancement in the technology, the devices are being more mobile and with the availability of the internet. It is not a big deal to have information or to view the information. But what kind of the information we are viewing, we are consuming, is it true? Because the false information is posing the biggest threat. We have the idea that deepfakes are the computer generated videos, audios, and the images where the individuals uh, have shown to do something or to say something that they have never done. And with the advanced neural networks and the GANs, the quality of this deepfake it is increasing day by day. This is the graph which shows how the deepfake content it is continuously increasing. So the deepfake detection here it is a more crucial so as to detect or so as to control the number of frauds, the cyber crimes. Then after that, the pornography, basically where the women are victims, then to spread to so as to regulate the spread of the disinformation or the rumors which specifically targets the political and the famous personalities, and to stop the public to stop the abuse, etc. So this is the literature survey which specifically covers the methodology, the data set, and what are the key contributions, and at the same time what are the limitations remain in their research. So from this literature survey what we come to know, whatever the work has been done, it can be divided into the two approaches. In the first approach tries to find out the particular anomalies or the inconsistencies which remains in the media, whether it may be the image or the video, and based upon that what will be the particular media file or the image, it will be detected fake or real. On the other hand, the machine learning models, the deep learning models are used, and they will classify that particular media file, it is whatever that particular image, it is a deep fake or the real. So what we come to know, no doubt the CNN based architectures are dominant here, but at the same time whatever the cost of this defect detection or the model, it is a very much high. Then they have the poor explainability or the limited interpretability. So the main problem is here, whatever the currently research it is going on, the computational cost is very much high and unsuitable for the real time or the low resource environments. So there is a need to have the more lightweight and the robust technique for the deepfake image detection. So here we are presenting the deepfake detection technique, which basically captures the texture and the gradient artifacts using the machine learning models. So this is the framework for the deepfake detection. So it starts with the image pre-processing. Now once the images are pre-processed, then the next step here is to to extract the features from that particular image. Now here the main motive is what, whenever any deepfake or the image is created or any image is manipulated, at that time the some kind of the inconsistencies are remain within that image. So the main focus is here, that is to try to capture those particular anomalies. So for this purpose we are using here the two feature descriptors, LBP and the HOG. So basically here the LBP feature descriptor extracts the textures from the images. On the other hand, the histogram of oriented gradients, it extracts the edge directions. Then after that, the grade changes in the gradients, the changes in the brightness, and extracts the shape features. the information about the shape of that particular image. Now, once these features are extracted, then it has been given as an input to the machine learning classifiers, which will finally classify the result as a whether that particular image it is a true, the original or the deepfake. The data set that we have used here, it is the publicly available data set from the Kaggle. Out of this, the 200 images are the original one and the 2000 images are the fake. That 70% data is used for the training and the 30% data is used for the testing. The performance matrix, this is the performance matrix that we have used here. Moving towards the result part here. So basically what we have done here, we are using the three different kinds of the machine learning classifiers, k-nearest neighbor, then the support vector machine and the classification tree. And the result is categorized, the single feature means the LBP, then the histogram of gradients, and then integration of the LBP and the hop. So what we have found here, that is when only the local binary pattern we are extracting. So at that time, the k nearest neighbor, the performance of the k nearest neighbor, it has been very good with the accuracy 97.9. For the only hop features, both the k nearest neighbor and this support vector machines, they are showing the accuracy near about the 98%. And when we have the integration both of the LBP and the hop features, so here the support vectors machine SVM performs slightly better with the accuracy 98.8. So this is the graphical visualization of this result here. So what we can conclude, that is, yes, the LBP captures the texture patterns, while the hop captures the structural and the edge information in the deepfake images. And with the integration of this LBP and hop, we can, with the integration, the performance of the deepfake detection, it is increased. Talking about the performance, so yes, the KNN performs the best for the LBP with the 97.9 accuracy. The hop performed for the hop features, the KNN and SVM, they are quite equivalent, around 98% accuracy. And whenever we have the integration, then here slightly the performance of the SVM is better. So in future, what we can have, the integration of the hybrid, we can have the hybrid machine learning and the CNN-based frameworks, so as to enhance the defect detection performance, then to have the real-time deployment. And at this time, we are just concentrating on the images. So in future, we will have to we will think about to work on the multimodal defect detection, so that it will consider both the audio and the videos. So these are the references that I have used here. Thank you.
Thank you so much for your presentation. Sir, do you have any questions? Sir, do you have any questions? Okay, I guess.
I don't have any question, ma'am.
Yeah,
Please
okay. I guess
continue.
no questions then. So we'll be moving on to the next presentation now. Next, we have Abhishek Talwar to present the paper titled Leveraging Text Analytics to Drive Innovation in Digital Investment Through User-Centric Insights, a study of Grow app reviews and sentiments. Are you there, Abhishek?
Yes, good morning. Can I share the screen?
Good morning. You may please begin with the presentation.
Is the slide visible now?
Yeah, it is
Hello.
visible now. You may please start.
Okay. Very good morning to one and all present here. My name is Abhishek M. Talva. Today I'll be presenting a paper on the title Leveraging Text Analytics to Drive Innovation in Digital Investment Through User-Centric Insights, a study on Grow app reviews and sentiments. This will be the flow of the presentation. So coming to the introduction, we know fintech or financial technology is the integration of technology to improve, automate, and deliver financial services, making the services very convenient to the users. And in the fintech industry, we can see there are a number of applications from mobile payments, online and mobile banking, budgeting, robo advisors, and brokerage services for investing in stocks and services. Coming to this fintech in India, there are a number of companies like Paytm, Credit, PhonePe, Grow, which provides the users an option to invest using mobile interfaces. In my study, I have focused on particularly Grow app on Google Play Store to understand what are the user reviews and sentiments towards a particular Grow app. So we can see that this Grow app is very popular. A number of people have downloading it and using it, from people from youths, colleges, professionals, and mostly middle class people are investing with a little amount they can, and investing in stocks, SIP, future and options, and commodities. But when we look at the reviews or about the usage of the app, we can see a mix of comments it can be negative, it can be either positive in the rating of 1 star to 5 star. So focusing on that, our motivation was to understand what was the reason for this, what are the factors that are leading to more positive reviews and negative reviews. So our research problem was there is a lack of research understanding the user experiences with investment apps. So this study applies sentimental analysis and topic modeling techniques on the user comments on Grow app. So coming to the methodology, we collected user reviews, online reviews from the Grow app from the Google Play Store for the year 2025 to get the recent concerns about the users, and we collected more than 155 reviews, and then it was filtered, data was cleaned, and the initial threshold for each comment was set to 150 words or 150 characters to make sure that each comments had some meaning out of it. And then we applied both sentimental and topic modeling, and then we applied correspondence, which we'll see later. So in the sentimental analysis, after data cleaning, we arrived at more than 4,949 reviews, in which mostly were neutral and positive. And we categorized them into 3-star ratings, like neutral was given 1, positive was given 2, and negative was given 3-star ratings. Then we applied a topic modeling and coherence score analysis. This is nothing but in topic modeling, it identifies a number of topics from minimum to 0 to 30 topics. And looking at the coherence scores, we can understand which is the optimal number of topics that can be identified by topic modeling. So we can see here that 5 topics were identified as the optimal number for the study with a coherence score of more than 0.6. So then, so the results show the topic features and word cloud. So it identified 5 topics, and also it gives you a top 50 comments from each topic. So we have to manually read the top 50 comments in each of the topic and understand what are the various factors or concerns in each of the topic. In topic 1, it talked about brokerage charges and app performance issues. Topic 2 was dropped because it mostly contained Hindi slang words. Topic 3 talked about user experiences and investment features. Topic 4 talked about customer support and service issues. And topic 5 talked about financial losses and the brokerage fees related and user complaints. Now we try to combine these two to understand what are the sentimental analysis, what are the sentimental scores, and what are the topics. And we try to identify what are the topics that are falling in different ratings. So the 4 and 5-star rating are associated with topic 3. So the positive sentiments were related to like app features, the usability, the pricing, the diverse investment products or services that are available on the app, and the user-friendly interface were the key reasons for the positive ratings. The 3-star user rating was not associated with any topics. As you can see in the graph, the topic 3 lies on the axis. So no topics were related to this 3-star rating. For 2-star rating, the The topics were brokerage charges and the app performance issues like the technical glitches and the brokerage cost of using the services very high. And user star one rating is associated with topics 5 and 4. It addresses customer support and service failure to resolve customers' issues in a timely manner, and also the financial losses in trading and investment that can lead to dissatisfaction towards these platforms and the user ratings. So based on these findings, the recommendations were to strengthen the core experience to maintain and enhance investment features and UI design, to make it easy to use investment options and retain and engage users, fix support and loss drivers to improve the customer support quality, resolve complaints promptly, and address issues related to financial losses and high brokerage charges to lift the user ratings, and to upgrade service infrastructure to implementing faster response time, robust complaint resolution system, dedicated help channels, and smoother onboarding for new investors. Aligning fintech policy goals to ensure the transparent communication on all the charges and risks involved in using this investment platforms should be made aware and should be communicated to the customers to enhance their trust and to capitalize on the strengths. To understanding those positive factors, it can be integrated into the marketing campaigns and to promote the app benefits. So thank you. This is about my paper.
Thank you so much for your presentation. Sir, do you have any questions?
No, ma'am, I don't have any questions.
Okay. So we'll be moving on to the next presentation. Next, we have Sahana S to present the paper title LLM Powered System for Academic Question Generation and Student Answer Evaluation. Are you there, Sahana?
Yes, ma'am. Am I audible?
Yes, you are audible. You may please begin with your presentation.
Yes, ma'am.
Your screen is visible now. You may please start.
Okay, ma'am. So my paper, good morning, everybody. So we have written a paper and we have researched about the concept of LLM powered system for academic question generation and student answer evaluation. So, what are the key motivation for our project and why we selected it? As we all know, academic question paper creation and student answer evaluation are still largely manual processes, making them time consuming, inconsistent, and prone to human bias. With increasing class sizes and maintaining fairness and scalability in assessment became challenging. So we are proposing LLM-based student question paper generation and answer evaluation. How to do it via AI. And obviously, when I teach about or talk about AI, the thing is obviously we have my biases and we have problems, and how to deal with it is all our paper. So while we are going with the humanized technique, we do have problems like time consuming and inconsistency and all that. Then I'm proposing a solution with AI. Obviously, AI do have problems. How to tackle that is going to be our problem statement. So that's the reason why we majorly selected like this project. So let's proceed with that. So what is the existing model which we have? Obviously, transformer-based models like BERT, ROBETA, T5 significantly improved grading accuracy by capturing contextual semantics, outperforming the traditional RNN-based methods in short answer evaluation and all that. Recent studies have also explored LLM-based grading system and multi-agent frameworks, showing better generalization and feedback quality. But highlighting the issues, as I mentioned earlier, there are issues in AI as well. But highlighting the issues such as hallucination and misalignment with human grading. So still now, what are all the solution proposed is RAG. So what is RAG and what are we going to do? So as of now, we have LLM proposed method. And while we are using AI and thinking about AI, it does have problem of hallucination and misalignment and all that. While marking the student's answer and all that, we do have problems, but they have earlier tackled with RAG. What is RAG and things I'll explain later when I'm talking about architecture and all that. So now, what is our solution? What we have proposed and what we have newly added to it is, as I earlier explained, we have RAG and all proposed earlier. So what we are including graph RAG now. What is graph RAG and everything? I'll explain when it comes to architecture diagram and all that. So we are proposing a LLM-based academic assessment system is proposed to automatically generate student structured 50-mark question paper and evaluate student answers using instruction tuned models such as Mistral 7 B, and Llama 3 via Grok API. So these are all the two LLM models which we are using, Mistral 7B and Llama 3 and all that. So what is the architecture? How are we supposed to do it? That I'm going to explain now. So first we have input parameters. So we are actually training this model based on a live data set and all that. So first is we have two categories. One is we are uploading our study material, the one which usually we get in college, right? Like PDFs, PPTs, or whatever it is. So we are just uploading that study material, or we are uploading student answers. So two modules we have, as we can see. One is evaluation module that is evaluating our scores and all that. Next one is question paper generation. According to the study material, it will generate question paper automatically, or else it will, if you upload the answer, it will evaluate automatically. So two modules we have that I'll explain. So first we have study material or student answers. Either we have to upload study material or student answers. Next, what is happening is, this is the most important thing, like where our novelty and things come, the RAG part and graph RAG part. So after uploading the study material, what is happening is, first we from the study material, we are using one spacey concept. Like spacey is a module that spacey will extract the study material into subject or verb and object. So there will be a lot in study material, like while we are speaking about PDF and all that, we'll be having a lot of things. So first our module will create a spacey material, will create important things like subject, verb, and object. Like for example, I'm telling, for example, we speak about cell division. What is the cell? First, cell is our object and cell is our subject, and then divides will be our verb. And what it does, cell division, that's our object. So like that, it will separate the whole module, whole study material into a graph. Then it will store. This complete process is called RAG, like chunking the material. That is called RAG. So that is stored in a ChromaDB databases. Before doing anything, after uploading the study material, the data will be stored in ChromaDB. Then our LLM comes into part. After that, we have two modules, evaluation module and question generation module. And what is our part? Graph RAG. That I'll explain later. Okay. Now, if we selecting the evaluation module, it will automatically, the reference answer which we have provided, this is the student answer. Then we are evaluating our answers with the study material, the knowledge from the study material, which we have in ChromaDB. This and the answer student have written will be compared, and it will be evaluated. Like out of 10, how much a student is getting, like that. And how accurate our model is it biased or is it not biased? I'll tell later. And while second module is question paper generation. That is, teacher can select whether to evaluate a student's answer sheet or to select the question, process the question paper completely. So that's our complete thing. So via this, our model is performing via this architecture. So how it is done? So the methodology begins by pre-processing the study material into fixed length of chunks. Simultaneously, our spacey, now here, spacey relational, it will extract triplets that I said, subject, object, and verb. So that is a basic thing. So now, how are we doing the result part? So we have scores to perform, we have scores and things to compare our results. So first we have F1 score. F1 scores deals about how relevant is the student student's answer with the AI generated, with the pre-processed answer we have. So earlier, this is the method which till now it is existing, RAG. This is our part, which we have included, graph RAG. So RAG, as I said, chunking the materials and storing before the answer generation or before the question paper generation or evaluating the answer, it will create a conceptual idea of what is there in the study material. It will chunk. That is called ragging. What is graph ragging? So here you can see graph ragging is just it will deal about only one graph. While you're talking about the knowledge graph, here, as I said, in cell division, you have multiple concepts. So it will extract all the relevant graphs which is there in the topic cell division, so that it will be even more easy every time. But when you use RAG is like, imagine this is a single graph and that will be your RAG. So if you go in a RAG method, whenever you want answer, whenever you want to evaluate a student answers, you have to again and again, you have to take like one graph, RAG graph. That then the time complexity will be O of n, order of n number of times we have to repeat. But when you take graph, at one shot, it will retrieve all the informations which is related to cell division, for example, you can see, and then the evaluation will be even more easier. And that's the reason why you can see graph RAG performs better. But obviously, it's time consuming and all that. So inference time is less when in RAG model comparing to graph model. So as of now, I consider this method we have achieved F1 score, ROGL, cosine similarity, and BERT score and toxicity score and everything is better in the model we propose, that is with graph RAG and LLM combined models. So this is the basic outlet of our project. Thank you.
Thank you so much for your presentation. Sir, do you have any questions?
Yes. Have you explored any LLM models?
Yes, sir. We have explored, as I said, Mistral 7B and Llama 3.
Llama 3. And for
Yeah,
that,
Llama.
have you worked on the GPUs or you have worked on a standalone laptop?
Standalone laptops only, sir.
Uh, so were there any issues while debugging or executing the code in case of using which LLM you have used?
Mistral 7B and Llama 3.
Okay, okay. In that case, it will work for the normal standalone laptop. Why not
Yes,
you
sir.
explore in other which requires a GPU feature so that you can get a good results?
Yes, sir. So that is a current extension of our project. Actually, we are extending this project again, and we are adding, our reinforcement learning also. That is the next step which we are doing. And next, as we have done in conceptual ideas like general knowledge and basically textual based, we have achieved this much accuracy. Now, what we are planning to do is about we are going to improve this for mathematical models and all that. So when we talk about that, obviously we are implementing and expanding the idea which you said currently. So we are exploring new models and all.
Now, whatever the results you have got, so to how you have compared it, to whom it compared.
Yes, sir. So basically, the results which we have got is like basically, as I said, we have taken a data set which is like live data set. We can upload any study material, like it might be a PDF or PPT, whatever it is. So our LLM does the part. Like LLM will extract one basic concept, like as I said, it will extract some basic concepts and it will store in a database and all that. Now it's a live system, actually it's an interactive system. Now a student or a teacher is uploading a student's answer, and we have already created a knowledge graph based on the study material which we have extracted. So now that is being compared with the student actual answer. So based on that, as I said, we have scores, F1 score, BERT score, and all that. So that's the comparison score based on the knowledge graph and the actual answer. We are comparing with BERT score and F1 score and all that. And that part, if you see, our graph rack produces more accurate results than doing n number of times with the traditional RAG method combined with LLM.
Okay, from my end, questions are over.
Thank you so much,
Thank
sir.
you, sir.
Thank you so much for your presentation. We'll be moving on to the next presentation. Next, we have Mugda to present the paper titled Quality Modeling by Ensemble Methods, a case study of the fused filament fabrication industry. Are you there? Mugdha, are you there?
Yes, ma'am.
Yeah, you may please begin with your presentation.
Yes, ma'am.
Can you please
Is
share
my-
your
is it not
screen?
visible? Just a
No,
minute.
no,
I'll just. Is it visible now, ma'am?
no, it's not visible.
Just a minute.
Can you share again?
Yeah, just.
Yes, it's visible now. You may put
Yeah,
on your.
I'll go to Scrya. Yes. Is it now visible?
Yes, it's visible, but I guess it's.
Okay.
Can you just turn? Yeah, yeah, correct. Now you can
Okay.
please. Yeah, start.
Okay, ma'am. Yeah. My topic is quality modeling by ensemble methods. I have done a case study based on FFF industry, that is fused filament fabrication industry. The I'll discuss the abstract now. Basically, we have taken the cellulose nanofibers and reinforced them into polylactic acid and prepared the sample. So after that, we have done this with the help of Topsys. We have done the mechanical testings, and with the help of Topsys, we have created the overall quality index and the uh, ensemble machine learning part is used to model the mechanical properties, out of which the adaptive boosting has given the highest prediction accuracy. So basically, FFF, that is fused filament fabrication, is widely used for polymers and composites. The mechanical properties, if we talk about, they strongly depends on the process parameters such as layer thickness, infill density, etc. uh, the traditional optimization, it is somewhat ineffective due to the conflicting outputs, because sometimes the tensile strength will increase whereas the young modulus may decrease. That's why it gives the conflict result. So for avoiding that, there is a need for unified index, that is overall quality index, for better decision making. The objectives of my paper are: we have collected the experimental data from various research articles, and that is for PLA CNF composites. Then we combined the outputs using the TOPSIS to form the quality performance index. This quality performance index was modeled with the four ensemble machine learning models, and then the performance metrics were compared, and the identification of best model was done. So this is the methodology of my paper. That is, we have collected the focus basically on the input parameters such as layer thickness, raster angle, nozzle temperature, infill density, and the filler percentage, that is the CNF percentage. Then we did the experimental investigation. We have worked on that using the Taguchi L27 array, and the responses were find out where they were the tensile strength, elastic modulus, toughness, and warpage. All the other first three, that has to be maximized, whereas warpage, the last one, has to be minimized. So after receiving the results, we can see that the combining of multiple responses was done with the help of TOPSIS. And after that, the models used were the random forest regression, gradient boosting, adaptive boosting, and extra regression. The evaluation factors that are considered are R square, root mean square error, and mean absolute and mean absolute percentage error. And then later on, the discussions were done. So filament was taken. These are the parameters. The filament was taken with the help of 1%, 3%, and 5% CNF integration. The layer thickness was chosen as 0.123 as in mm. The nozzle temperature was 190, 200, and 210 degrees Celsius. The raster angle selected was 0 degree, 45 degree, and 90 degree. The infill density was considered for 20%, 50%, and 80%. And as I said, filler percentage was 135%. The Taguchi L27 array was used, and the tensile specimens were done with the 638 ASTM standards. The output parameters were tensile strength, toughness, elastic modulus, and warpage. These are the results we have. These are the hyperparameters we have selected. So n estimator values were taken for different models, and likewise the maximum depth and sample split and bootstrap. The model gave the as we can see here, the adaptive boost regression has given the better performance as compared to the other models, whereas random forest and gradient boosting has given very poor performance. The comparison of the R square test is as shown. The ABR has reached around 0.9%, 0.9, sorry, and whereas the random forest has not just passed, it is very less, like 0.25% test. The results are like shown here. R square, you can see adaptive boosting has given 0.94, and whereas the random forest has given 0.25, and other four other two models, that is gradient boosting and extra T, were given the 0.44 and 0.82 value. The results were the adaptive boosting has given highest prediction performance. Also, extra tree has performed very nicely, but random forest has given the lowest accuracy. So effectively, we can say that overall quality performance index have given the have captured very combined behavior. Okay, so future scope for the presentation is the artificial neural network or CNN or LSTM models can be used for deeper set. The data set can be expanded, and real-time quality monitoring can be also done with the help of sensors. So these are the references we have used. That's it. Thank you.
Thank you so much for your presentation. So, do you have any questions?
I don't have any question, but the ma'am has presented the paper very perfectly, so there is no any lacuna over there, and everything they have
So, we'll be moving on to the
crystal
next.
clear.
Yeah.
Thank you, sir. Thank you.
So, next we have Bhuvaneshwari to present the paper titled Spatiothermal Deep Learning Framework for Dynamic Forest Fire Risk Forecasting in the Nilgiris District, Western Ghats. Are you there, Bhuvaneshwari? Bhuvaneshwari, are you there? Yeah, I'm unable to hear you. Your mic is unmuted. Uh, Bhuvaneshwari, we cannot hear you. No, we are not able to hear you. Hmm. We're not able to hear you. Hello. I guess there is some network issue or connection failure from your end. So you can just, get well with it and then come back to the meeting and please drop a text in the chat box. Till then, we'll be moving on to the next presentation. Next, we have Yuvraj to present the paper titled Understanding Sarcasm Online Mechanism, Challenges, and Impacts in Social Media Disclose. Are you there? Yuvraj, are you there?
Yes, ma'am. Yes, ma'am.
Yeah, you may please begin with the presentation. Okay.
Screen is visible, ma'am?
Yeah,
No, fine. Thank you. Thank you, ma'am.
just
Thank you
give
so
me a
much.
moment. I guess Bhuvna is also sharing her screen, but Bhuvna, I cannot hear you. So please get your mic corrected, and then we can move ahead with your presentation after this one.
May I start, ma'am?
Yeah, sure. You may
Okay.
please start, Yuvraj.
Yeah, thank you. Good morning, all. Good morning, one and all. So my paper name is Understanding Sarcasm Online Mechanism Challenges Impact in Social Media Disclosure. This is the outline for my presentation. We'll start with an introduction. So in introduction, we'll start with an first sentiment analysis. So sarcasm is the term which is utilized by the intelligent individuals on website which is focused on blogs and social media. So it is employed to convey the oblique information about claims that are already trending in on a social media. So we know that million of people publish all kind of judgments on everyday opinions on this social media platform or any other media platform. Uh, it is practice of locating and gathering sarcastic remarks made by the internet users in support of specific opinions or attitudes. So when we talk about an sarcasm dictation system, which is employs a variety of approaches, which includes, let's say, context-based, rule-based, pattern-independent, and one more is what machine learning approaches. So the system uses techniques which include SVM, that is support vector machine, random forest, Navier-Bayes model with maximum entropy to access Twitter data sets, sarcasm identification and detection. So every day, a significant amount of data is produced in a greater volume. According to the data from Global Web Index, the number of mobile users has climbed to 3.7 billion. And this is a huge amount of users, which yearly increase over 17% approximately. So individuals are more comfortable for sharing their thoughts, opening up on a social media platform about event, products, and company tactics. So we can imagine how n number of data is produced on a daily basis. So this figure shows that the sentiment analysis has some positive, neutral, and negative things. So people frequently use sarcastic remarks to make the light of others, which is okay, fine. But it may be harmful when sarcasm is used to dispraise specific people, some concepts, or events. So this type of sarcasm is prevalent on social media platform, definitely. So particularly those like platforms like a Twitter, where users.
Rahul sir.
Hello. Yes, sir.
Hello, Rahul sir. Can you just focus on the main contribution of your paper rather
Yeah.
than
See, basically, so this is my survey paper, as this is my very first paper. I'm focusing on what exactly it is, motivation behind this. As we discuss that the see n number of social media platform available right now, so huge data amount of data is produced. So my basic aim is to identify or to study some existing study which are available in right now in the market, and find out which is the best and the gaps between these, and on that gap we want to work ahead. So see sir, so this is literature survey. So in this section some similar work of subject and gap analysis will be discussed. I have surveyed 20 to 25 papers till now, and among that we are finding out existing methods are there, some rule based approaches are there, machine learning approaches are there, support vector machine approaches is there. uh, huh. If this we concentrate on this figure, so there are four primary methods used in sarcasm detection: rule based, pattern based, machine learning approach, and context based approach. So the fundamental method for identifying sarcasm is user posted comment is rule based. So in the rule based method is mostly concerned with the hyperbolic and synthetic elements. So the rule based method are very easy to use and usually produce the actual text classification. So for effective sarcasm detection, both user and the system needs to understand the tweet's context. And to improve more accuracy, this context should be aligned with the general knowledge. So in the gap analysis, we found that in the view of literature survey were carried out, we found that a sarcasm prediction is very important when people use it to give an opinion about something new event, product, or else. Therefore, accuracy plays a crucial role in this. So one more thing is real time data is required to use instead of a static data set. Then this is one more thing. And so instead of only considering text from user, to consider context of text may help to improve the sarcasm prediction. So the problem statement from this, I have found that huge data is exchanged on social media day by day. And but obvious when we use social media on that huge context, it is increasing in tremendous volume. Due to this, it is rise in a data, number of challenges are faced like data storage, processing of the huge amount of data, verification of exact orientation of data. So in the view of this, the research aim is to propose accurate sarcasm prediction algorithm which uses context of text and apply learning techniques to relate the context of text to general problem in social engineering context. So the methodology, I want to show the diagram. Yes. So here we first start with a data collection. So this is the outline how data is obtained from the Twitter API. So about 70% of data set is model training and evaluation, while 30% for model is testing. So data is collected from the user posted tweet, but obvious from the Twitter API. To gather this sarcastic content, a query is sent through an API targeting tweets that including hashtag sarcasm. So then data processing, sampling the data set and modeling blooming, then model assessment will be done. Then the examination, the data set used to conduct final and objective assessment of chosen model using training data set will known as a data set. For the chosen model, testing data set is an entirely new and untested data set. A data set is also referred to an holdout data set if it is brand new and not included in a training data set. And here we decided some assessment criteria. So experiment will be conducted on the data once all the features have been extracted. So the methods are recall is there, F score is there, precision, and most important or crucial is what? Accuracy. So we found that the problem with sarcasm is what? Annotation problem. The problem is with sentiment as a feature, unbalanced data set issue. So these the problems we identified. Some methodologies I have identified, which is fuzzy logic inference is there, fuzzification using a triangular and trapezoidal membership function, defuzzification via centroid method. See, we used the Twitter API dataset, then tools Python or MATLAB, evaluation matrix, precision, recall, and we splitting the data set as but obvious training data set, testing data set, 70% training data set and 30% testing. So yeah, so this article is nothing but a comprehensive analysis of research on sarcasm identification, focusing on data set, a source from the social media platforms like Facebook, Twitter, or we can say e-commerce websites. We identified 4 primary detection methods: rule-based, pattern-based, machine learning-based, and one more is context-based, along with a specific feature utilized by each approach. So here we highlight or try to highlight the current trend in sarcasm detection and discuss the challenges we encountered when attempting to identify the sarcasm in written content. So these are the references. Thank you so much for giving me opportunity.
Thank you so much for your presentation. Sir, do you have any questions? Sir, do you have any questions?
No, I don't have any questions because it's a literature survey paper.
Okay, thank you so much. So we'll be
Thank you.
moving on to the next presentation. Next, we have Bhuvneshwari to present the paper title Spatio-Temporal Deep Learning Framework for Dynamic Forest Fire Risk Forecasting in the Nilgiris District, Western Ghats. Are you there, Bhuvneshwari, now? Bhuvneshwari, are you there? I'm unable to hear you. We are unable to hear you. Can you join from some other device?
Yeah, can you able to hear me now?
Yeah, I can hear you now. You may please start with your presentation.
Yeah, sure. Sorry for the interruption, ma'am.
It's okay.
So I hope my screen is visible.
Yes, your screen is visible. You may start.
Yeah, so my paper title is Spatio-Temporal Deep Learning Framework for Dynamic Forest Fire Risk Forecasting in Nilgiris District, Western Ghats. So myself, Bhuvneshwari Haridas. So I am from SRM Institute of Science and Technology. So my flow of presentation, is my slide moving? Hello, is my slide is visible?
Yes, your slide is visible, Bhuvneshwari.
Yeah, so this is my flow of presentation. I'll be starting with the introduction, then gradually I'll be explaining about the research gaps, research objectives, what are the data sources and integrations that I have used, methodology, finally the results and future scope and suggestion. So coming to the introduction part, from the recent studies between 2020 and 2024, so we came to know that there are many fire incidents have been reported in Nilgiris, especially like around 37 forest fires have been reported in Western Ghats, Nilgiris district. So forest fires have become a serious and recurring problem, especially in the fragile mountain ecosystems like Nilgiris and Western Ghats. So this region is very sensitive because of steep slopes, mixed vegetation, and strong dry season winds. So because of this, the geographical location, like what I have taken is the Nilgiris district, which covers about 2,550 kilometers square, and the rolling highland terrain in Tamil Nadu. So the elevation is about 600 meters to over 2,600 meters. So this is the literature survey. I have gone through around 25 to 30 papers, and I have selected about 8 papers here where I have collected major information about the methodology used, dataset used, and also the merits and demerits. So based on the literature survey, like when I reviewed all the existing literature papers, the few gaps become very clear. That is, most studies produce forest fire risk maps only after the fires have already occurred, so which actually limits their usefulness for prevention. So many approaches also treat space and time separately. They either focus on the forest fires once it happens or when they happen, but not combined together. So in addition, the spatio-temporal deep learning models are still rarely applied in the Indian forest regions. And another important gap is the explainability AI part. Many models act like a black boxes, which makes it very difficult for the forest officials to trust and adopt them. So based on this literature analysis, the research objectives, the main objectives, whatever I have taken, I have listed over here. So first of all, to build an AI system that predicts the forest fire risk dynamically and also in advance. So to achieve this, multiple spatial and temporal data sets are integrated to understand how risk actually builds over time. So the study basically compares the traditional machine learning models like random forest, XGBoost with the spatio-temporal deep learning model, convolutional LSTM. And also the explainable AI techniques are used to understand the key risk drivers. And finally, the goal is to provide a early warning risk maps that can support the real decision making for the forest officers. So coming to the data sources, I have collected the data sets from different sources. Like one is from Moody's for deriving the data set like vegetation health and land surface temperature. And the other data sets like weather variables such as temperature, rainfall, humidity, wind are taken from ERA 5 reanalysis data, terrain data from Copernicus DEM, and also land cover data from ESA World Cover. And the historical fire occurrences are obtained from NASA FIRMS. And all the data sets are harmonized into a common 500-meter grid. Since there is a high risk of fire cases and and also it is like the SMART analysis is applied to balance the data set. Why? Because if the data set is imbalanced, then the result will not be accurate. So to avoid that, I have used the SMART analysis. And this is the methodology that I have used. So I have used 3 different algorithms, like one is random forest, the other one is XGBoost, and the final proposed model I have used is the convolutional LSTM. So why I have chosen this baseline model is most of the research papers I have seen, they have used random forest and XGBoost and shown the accuracy of more than 85%. So I thought of using an advanced deep learning model, convolutional LSTM, in order to prove that the accuracy shoots up above 90%. So that's the reason I have chosen these 3 models, and comparatively I have achieved a good result. And this is the model-wise configuration I have listed out here. So each model was carefully configured to ensure a fair comparison. The random forest was designed to reduce the variance by averaging multiple decision trees. The XGBoost was tuned to capture complex nonlinear relationship between the variables. And for convolutional LSTM, the input was structured as a sequence of weakly spatial grids, allowing the model to learn the gradual changes in the fire risk. And all these models were trained and evaluated using the same data set and the metrics ensuring for the consistency across different comparison. And this is the results and comparison that I have listed here. So when we compare the performance, convolutional LSTM clearly outperforms random forest and XGBoost across evaluation metrics, While the traditional models captures general risk patterns, they struggle with long-term temporal dependencies. But whereas the convolutional LSTM performs better because it understands how factors like rising temperature and drying vegetation accumulate over time. So this results highlights the importance of spatio-temporal learning for accurate forest fire risk predictions. And coming to the spatial validation part, the predicted fire risk shows strong spatial alignment with historical fire events, and most FIRMS fire points fall within the areas predicted as moderate or high risk. The high risk clusters appear consistently around the region. We could see the Kunnur, Kunda, and Wenlock Downs, especially near plantation and forest boundaries. Temporarily, the fire risk peaks between February and April, which closely matches the real world observation by forest officials. So, this basically confirms that the model captures both spatial and seasonal fire behavior accurately. And coming to the explainability, SHAP analysis I have used for explainability AI to understand why the model makes certain predictions. So we have the analysis shows that the declining NDVI vegetation type and increasing temperature are strongest contributors to the higher fire risk. On the other hand, the rainfall and humidity reduces the fire probability. So these patterns align well with the ecological understanding, which increases the confidence in the model. Explainability is crucial because it helps translate AI outputs into insights that domain experts can trust and use. The policy and implications, we could see that the key implication of this work is through shift from the reactive to preventive fire risk management. By forecasting risk in advance, forest departments can able to plan patrols, allocate resources, and also act before the fire occurs. So the framework is also aligned with SDG Goal 13, which focuses on climatic action. So in conclusion, the proposed spatial temporal framework successfully forecasts the forest fire risk in the Nilgiris with convolutional LSTM as the emerging and most effective interpretable model. So the last part, coming to the future scope and suggestions, there are several ways to extend this current work. So one important improvement is addressing cloud cover issues by integrating sensors like Sentinel-1 SAR data, that is directly integrating with satellite data. The advanced models such as transformers can be explored for longer range forecasting. So the framework can also be tested in neighboring districts to evaluate its generalization. And finally, to integrate this in real-time satellite data that can make this system operational and continuous fire risk monitoring. So these are my references based on the literature analysis, whatever I have done. Thank you. Thank you all.
Thank you so much for your presentation. Sir, do you have any questions?
No, I don't have any question. Please move to the
Okay.
next presenter.
So we'll be
Thank
moving ahead with the next presentation. Next, we have Osh to present the paper title Using Machine Learning and AI to Recommend Personalized Learning Methods Based on Student Profiles and Performances. Osh, are you there?
Hello, ma'am. Can you hear me?
Yeah, I can hear you. You may please begin with the presentation.
Okay. Can you see my screen? Is my screen visible? My slide?
Once it's visible, yeah, it is visible now.
Okay. So, good morning, everyone. My name is Osh, and today my research work is on using machine learning and AI to recommend personalized learning methods based on student profile and performances. So the content that I'll be covering in today's presentation is introduction, literature review and methodology, data collection and process, future enhancements, and conclusion. This is a survey-based research. So how did I come up with this topic and why did I choose this topic? So education is very crucial today for many things, and it is very important to understand each aspects while you're learning new topics, while you're learning something. And it's very significant to understand each topic. And while studying and while learning in different classes, I have noticed main three categories of students. There are students who understand things right away. There are students who gradually understand and consciously take their time to understand. And there are students who struggle to understand. So in this paper, I focused on student number 3 who struggle to understand and require more time and support in understanding different concepts. So, but students don't all learn in the same way as I've mentioned. And in this research, as I've mentioned, I'll be focusing on student number 3. So the traditional teaching method has failed to uh, teach students, and there are certain students who get categorized into the third category, which is sterling students. And while there are AI powered platform that has made progress, but they still need provide more quick answers, and they're still lacking in some areas which there are still students there who struggle to understand certain topics. So in this research paper, I would like to bridge the gap between between the traditional learning methods and the newly learning methods by using the help of AI ML. Together with these AML methods that I'll be mentioning in my methodology part, which is the hybrid machine learning method, I would like to advocate on creating more. Together with these methods, I would like to create a personalized engine that adapts to each student's needs while remaining scalable across diverse learners. To validate this result, a survey was conducted among engineering students and undergraduate, postgraduate, and PhD students to understand if these type of learning platforms will be useful for them, or will it benefit them in the future. So, as I've mentioned, this is a survey-based research, and the paper will advocate for AIML-based personalized learning techniques to adapt with students' past academic performances, current learning behavior, and there has been a survey conducted to get an insight to gather students' perspective on this specific AI platform, or whether how will they help, how will they contribute in their learning methods, and how will they improve them. And the questions that were covered in the surveys were different learning methods, preference across student types, and also a hybrid machine learning approach has been proposed for the implementation. So in the literature review on a digital recommended system for personalized learning, there were several different studies that I came across, and others highlighting the promise of students modeling and personalized recommendation, but they often fail to fully adapt to individual learners' profile. Comparative analysis shows different recommendations techniques, yet they lack behavior adaptation and real-world personalization. Other research focus on specific contents, primarily education and stuff. On these approaches struggle to generalize across diverse learners, especially in emerging and STEM education. Several papers emphasize challenges such as limited learner engagements, missing feedbacks, underutilizing adaptive mechanism, even algorithm approach and AI-driven strategies fall short in validating diverse learner and or addressing emotional and social aspects of personalization. Taken together, the literature shows a strong progress, but recurring gaps, limited adaptability, lack of behavior and emotional personalization, weak domain-specific focus, and insufficient learner feedback. So this research addresses those gaps by advocating for these types of platforms to be there, and also would like to propose a hybrid machine learning framework that combines classification, clustering, and collaborating filterings. So the model will predict students' profile and performances by their learning style and paces. Next, I'll move on to the methodology. As mentioned, there was a survey conducted, and the target of the surveys were UG students, PG students, and PhD students. And my purpose was to understand student perspective on a personalized learning platform. The structure of the questions were questions on learning preferences, challenges, feedback on an AI/ML-driven personalized model, and the outcome was getting insights to use this to validate and refine the proposed framework. So these were the questions that were asked. Mostly the questions were, as I've mentioned, were asked mainly on knowing how their experience is now on learning approaches, how different learning approach will help them or benefit them, depending on whatever they're learning, mainly education, how strongly They would recommend different types of learning which can be applied in different systems. And also there were some feedbacks that were gathered. So the responses received were profoundly different depending on the background of each of the study batches. While undergraduate students want clarity, postgraduate students want and PhD students want to understand the concept. The difference in responses highlight the importance of having tailored AI/ML recommendation, as this will help students from various backgrounds learn at their own pace and understand their own ways. Additionally, it confirms that each student, regardless of their category, whether they are toppers, average students, or struggling students, they can receive significant support from the recommended personalized learning methods. And also, based on my question that I saw, I also had a feedback session. So based on the feedback, at the end of the survey, there was a feedback. So participants were allowed to provide their own feedbacks. While some students found this research an impressive and much needed system based on the answer they have provided, based on the answer that were given in the survey, others suggested ways to improve the recommendation, such as making it more friendly, emotionally intelligent support system, and would help with dealing with academic stress and confusion and provide motivations. And some respondents stood out. So the respondents that stood out were balancing the fairness between finding the midpoint between helping struggling students and keeping that fairness in practice methods. It emphasized that personalization in main points, the main knowledge being given to the students shall be consistent. Also, there's another point which was mentioned, which is repetition is needed for more profound understanding by continuously giving same task by changing the difficulty, which allows them to apply the same concept in various ways, helping students apply the knowledge in multiple formats. So based on the question those were asked, based on the people who responded to the question, the surveys, everybody suggested different ways. As mentioned, some wanted it to be friendly, emotionally intelligent. Some wanted to understand the concept. So people had various feedbacks based on the platform, which also emphasized that these type of platforms will really be useful for different types of students. So based on the survey result, as you can see, the histogram shows and how average recommendation scores are distributed among survey responders. On the x-axis, you can see the average recommendation score, and on the y-axis, the frequency indicating how many responders had an average recommendation score. So the histogram illustrates that the distribution of recommendation score, for instance, a taller bar in the specific range indicates that more responder has an average recommendation score within that range, making it clear that the general sentiment towards personalized learning methods among the survey responders is high. The scores are skewed towards the higher end, suggesting a generally positive sentiment. The histogram proves that having such tools can boost students' skills and improve their overall performance in studies. The distribution of average recommendation score can provide insights to a general sentiment towards personalized learning methods among the survey participants. Engineering students comprising undergraduate students, postgraduate students, and PhD students filled out a survey which clearly indicates as follow and also proves that these type of
Sorry
systems
to
will be.
interrupt you, ma'am, but you have 1 minute to conclude your presentation.
So this is the hybrid learning method I would like to propose, which is the classification method, clustering method, and collaborate filtering method. And in the classification algorithm, it will predict students' performances and identify learners needing additional support. And then there's clustering techniques, and then there's the collaborative filtering techniques, and then there's the personalized edit. So this is the hybrid ML proposed framework I would like to propose for this. And for the future enhancements, I would like to implement these. And also the research stated that the research aimed for struggling students, but as I was working on this research paper, I found that overall it can all benefit all three categories of students, whether they are toppers or consistently learning or need for help. And personalized e-learning can be enhanced by integrating 5 key educational theories: behavioral, cognitivism, constructivism, and connectism, and humanism. These really can help explain how learner grasps analysis and apply knowledge. these types of tools must be designed and reflect on implements. These principles truly support diverse learners. Overall, I think these types of system will be really, really beneficial no matter which category you fall into, as were three of the tops were mentioned or any other category they fall into. Thank you.
Thank you so much for your presentation. Sir, do you have any questions?
No, I don't have any questions. So please move forward.
Okay. So, I sincerely want to thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough for all of you. We, on the behalf of the whole team, thank you for the support during this 10th version of the conference and all the previous 9 versions. We will be happy to have you in the 11th version in 2026 as well. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months, so kindly cooperate with the team of ICTCS 2025. Before wrapping up the session, I would also like to take a moment to thank our session chair, Dr. Suresh Limkar, for chairing this session. Sir, this is a token of appreciation to the chair on the behalf of the whole team of ICTCS 2025 and Global Knowledge Research Foundations and partners. Would you like to share a quick closing remark with us?
Yes, yes. Thank you for acknowledging me. And second thing, most of the authors, or almost all the authors, have work on the real-time challenging situations with the help of AI, and that will definitely will lead to the Vikasit Bharat as the government initiative. And that's it from my end.
Thank you so much for your presence. I would request everyone to kindly turn on their cameras for a quick snapshot before we end the session. Thank you so much, everyone. Thank you so much for your valuable presence.
Anjika, can you share with me?
What's yeah, the picture?
Yeah, group photographs, and in the certificate, just correct me. So instead of professor, just put doctor only.
Okay, sir, I'll just pass on the information. Thank you.
Yeah, sure.
Yeah.